There's a $1 bottle that can turn dirty, unsafe water into something you can actually drink. Not a weaker version, not slightly cleaner, safe enough to trust. And people have been using this exact method for centuries. Most people walk past it every day without realizing what it can do. It sits on store shelves, usually in small plastic bottles, often used for something completely different. But when it touches contaminated water, something almost invisible happens. Within minutes, the murky brown liquid begins to change. Tiny particles clump together. Bacteria lose their grip. The water begins to clear itself from the inside out. This isn't a modern invention. It's not a startup product. It didn't come out of a lab last year. The story goes back thousands of years. In ancient India, around 2000 BCE, Sanskrit texts described a simple but powerful method. People would take crushed seeds from a tree, mix them into cloudy river water, and watch as the impurities sank to the bottom. The water on top became clear enough to drink. No electricity, no filters, just nature and patience. Half a world away, along the Nile River in ancient Egypt, records show that people used plant-based coagulants to settle dirt and contaminants. Clay jars filled with river water would be treated with natural substances, stirred slowly and left to rest. What started as thick, brown water would separate into layers. The clean portion could then be carefully poured off. The Romans refined this idea even further. By the time of the Roman Empire, engineers were already experimenting with mineral-based purification methods. In places like Pompeii and Ostia, sedimentation basins were used to clean water before it entered the city. They understood something critical. You don't always need to remove contamination directly. Sometimes you just need to make it fall out of the water. In West Africa, communities used crushed seeds from the moringa tree. When mixed into water, these seeds released natural proteins that acted like magnets. They attracted dirt, bacteria, and suspended particles, pulling them together into larger clumps that sank to the bottom. The water didn't just look cleaner, it actually became safer. What's remarkable is that these civilizations had no contact with each other, yet they all discovered the same principle. Different continents, different materials, same result. That's not coincidence. That's convergent knowledge. Fast forward to the 1800s. European scientists began studying these traditional methods. In 1865, researchers in France documented how certain salts could cause suspended particles in water to bind together and settle. By the early 20th century, municipal water systems in cities like London and New York were using similar principles on a massive scale. And then came the scientific explanation. The secret lies in something called coagulation. In simple terms, most dirt, bacteria, and tiny particles in water carry an electrical charge. Because they have the same charge, they repel each other and stay suspended. That's why dirty water stays cloudy. Everything is floating, refusing to settle. But when you introduce the right substance, something cheap, simple, and widely available, it neutralizes those charges. Suddenly, those particles stop repelling each other. They stick together. They form heavier clusters. And gravity does the rest. The water clears itself. It's almost like flipping a switch. In 2012, researchers at Penn State University revisited the use of natural coagulants like moringa seeds. Their findings confirmed what ancient civilizations already knew. These substances could remove up to 99% of bacteria under the right conditions. Not 10%, not 50%, nearly all of it. Let that sink in. A method that costs less than $1. Matching results that modern systems charge thousands for. So why don't you hear about this? Why isn't this taught in schools? Why isn't it common knowledge? Why do most people still think clean water requires expensive filters, complex systems, or branded solutions? Because at some point, this knowledge stopped being convenient. And then someone, somewhere, did the math. If these kinds of forgotten methods matter to you, subscribe and ring the bell. Because once knowledge like this disappears, it doesn't come back easily. And this is just the beginning. Because the moment this method proved it could replace expensive systems, everything changed. That's when the industry noticed. Think about the global water purification industry for a moment. As of recent estimates, it's worth over $300 billion worldwide. That includes bottled water, home filtration systems, chemical treatments, emergency purification tablets, and large-scale infrastructure. Now ask yourself a simple question. What happens if people realize that a $1 solution can do a large part of that job? A cheap, accessible method that works without electricity, without replacement filters, without subscription-based cartridges. It doesn't fit the business model. A one-time, low-cost solution doesn't generate recurring revenue. It doesn't require brand loyalty. It doesn't scale into a billion-dollar industry. So what happens instead is something much quieter. The method doesn't get banned. It doesn't get erased. It just stops being talked about. Over time, the same basic chemistry gets repackaged. Instead of simple, accessible substances, you get branded purification products. Instead of a $1 bottle, you get systems that cost $50, $100, even $300, and many of them rely on the same underlying principle, coagulation and flocculation. But now it has a different name. A different label, a different price. In many cases, the active ingredients are hidden behind complex chemical terms. Aluminum sulfate, ferric chloride, polymer blends. These sound advanced, technical, and proprietary, but the function is identical. Neutralize the charge, clump the particles, let gravity separate them. That's it. And yet, the average household is taught to believe that safe water requires expensive hardware. Think about every plastic water bottle you've ever bought, every filter cartridge you've replaced, every advanced purification system advertised as essential. Now imagine if even a fraction of that could be replaced with a method that costs less than a cup of tea. Think about that for a moment. This isn't about conspiracy, it's about incentives. Industries don't need to hide knowledge aggressively. They just need to outcompete it, outmarket it, and outprice it until it fades into the background. There are also regulatory layers. In many regions, only certified systems can officially be marketed as safe for drinking water. That means simple, low-cost methods, no matter how effective, don't get promoted at scale. They don't get shelf space, they don't get advertising budgets, so they stay where they've always been, in rural communities, in survival manuals, in the margins of history. Meanwhile, modern science continues to quietly confirm their effectiveness. Studies from institutions like the World Health Organization and various university research labs have repeatedly shown that low-cost coagulation methods can significantly reduce turbidity and bacterial content in water. In controlled tests, properly applied coagulation can remove up to 99% of suspended particles and a large percentage of harmful microorganisms. Not perfectly sterile, but dramatically safer. And here's the part most people miss. This method doesn't replace everything. It's not magic. But it does something incredibly powerful. It turns dangerous water into manageable water. Water that can then be further treated, boiled, or filtered with far less effort and far higher success. It's a force multiplier. It reduces risk. It buys time. It increases survival odds. If you've watched this far, you already understand more about water purification than most people ever will. Subscribe and share this, because knowledge like this spreads person to person, or it disappears. Now let's bring this back to you, your home, your environment, your everyday life. Because the real power of this method isn't in history or theory. It's in how simple it is to use. And once you see it in action, you won't look at dirty water the same way again. Here's exactly what to do. And it's almost insultingly simple. You're looking for a small, inexpensive bottle of a basic coagulant. In many places, this could be something as simple as alum, often sold in grocery stores, pharmacies, or local markets for under $1. In other regions, natural alternatives like crushed moringa seeds can be used the same way. The cost is minimal. The effect is not. Start with a container of dirty water. It could be cloudy tap water, river water, or stored water that has visible particles. The more sediment you can see, the more dramatic the result will be. Take a small amount of the substance, just a pinch, roughly half a gram for a liter of water. If you're using a solid form like alum, you can rub it along the inside of the container, or dissolve a small piece in a separate cup before adding it. Stir the water slowly for about 1 to 2 minutes, not aggressively, just enough to distribute it evenly. At first, nothing seems to happen. Then within a few minutes, you'll start to notice something subtle. Tiny particles begin to gather. The water develops faint streaks, almost like smoke moving through liquid. Those are clusters forming, impurities binding together. Give it 10 to 15 minutes. Now look again. The difference becomes obvious. What was once cloudy starts to clear. The heavier particles sink to the bottom, forming a visible layer of sediment. The upper portion of the water becomes significantly clearer. Carefully pour off the top layer into another container. Avoid disturbing the sediment at the bottom. At this stage, the water is not perfectly purified, but it is dramatically improved. From here, you can boil it, filter it through cloth, or use additional purification steps. But those steps are now far more effective because the bulk of the contamination is already gone. Total investment, about $1 and roughly 20 minutes of your time. Compare that to the cost of commercial filtration systems, replacement cartridges, or bottled water over time. Now, consider a real-world example. In rural Kenya, communities have used moringa seeds for water purification for generations. In one documented case, a small village reduced waterborne illness rates significantly after adopting this method consistently. The change wasn't theoretical. It showed up in fewer hospital visits, fewer infections, and improved daily health. The science behind it is simple. You're not cleaning the water directly. You're changing the behavior of everything inside it. You're forcing contamination to reveal itself and then fall away. And that's why it works, long term, because it's based on fundamental chemistry, not branding. Roman engineers knew it, West African communities knew it, ancient Indians knew it, even early modern scientists documented it. And at some point, your great-grandparents probably knew it too. But today, a $300 billion industry depends on you not knowing it. Not because it's secret, but because it's simple. This knowledge never disappeared, It was just priced out of your awareness. And the moment you see it work with your own eyes, something shifts. You realize that not every problem needs an expensive solution. You realize that sometimes the most powerful tools are the ones history quietly left behind. Chemistry doesn't care about branding. Gravity doesn't care about marketing. And nature has never charged a subscription fee. Every time you share knowledge like this, you bring it back into the light. Every time you subscribe, you help keep it alive. Because there are still countless methods like this, buried, ignored, and waiting to be rediscovered. The next vault opens soon. And what's inside it might change the way you look at everyday objects forever.